Hi, my name is Greg Bachmanek and I'm an applications engineer with Hittite Microwave. At this year's MTT in Montreal, Hittite is demonstrating a complete LTE-A transceiver system. In our demonstration, we're using an Agilent EXG signal generator to generate the baseband I and Q LTE-A signals, and we're passing them through our transmitter board, which is composed of all Hittite devices used for modulation, attenuation, and filtering. And the key component which really has the highest impact on the overall system performance is the local oscillator, which is a Hittite frequency synthesizer. And as you can see on this screen here, at 2 gigahertz, the in-band phase noise is a superior minus 115 dBc per hertz at a 10 kilohertz offset and minus 113 dBc per hertz at a 100 kilohertz offset. As well, the noise floor is at least 20 dB better than is available from anyone else on the market today. It approaches minus 170 dBc per hertz. And again, this is all at a 2 gigahertz carrier onto which the INQ baseband LTE signals are being placed. What we do afterwards, coming out of the transceiver, is we split the signal off in two different directions. One of the pieces of equipment that we have analyzing the output signals is an Agilent PXA signal analyzer. And as you can see, the full 64 QAM is being captured, and we have a really amazing EVM number of minus 47 dB. And this is all driven again by our high performance Hittite PLL VCO wideband fractional lens synthesizer. Let me zoom in on one of the constellation points just to show you how accurately we are capturing everything. You can see here that hundreds of channel carriers are accurately hitting the bullseye of the 64 QAM constellation point. And again, this is driven by the high performance of the PLL VCO wideband frequency fractional lens synthesizer. If you were using a device that had much lower in-band phase noise, then you'd see the EVM number go down and you'd see the constellation points actually spread out. But fortunately, using a Hittite device, that is not the case. What we're also doing is we're splitting off the signal in another direction, and we're doing a direct down conversion using a Hittite created board as well. And on this board, we have a complete direct conversion receiver solution. It's RF to bits using all Hittite parts, a demodulator. Again, we're using another PLL VCO wideband fractional lens synthesizer for the down conversion. We're using all Hittite components for the baseband handling of variable gain amplification, low pass, sixth order Butterworth filtering. And Hittite also has really high performance low power ADCs, in this case the IMS2012. And then we pass the signal into a Xilinx board, and it is capturing the data here, as you can see, in INQ, and the INQ is being converted by FFT into the frequency domain, and you can see it's been downloaded or down converted to 25 megahertz, and it matches the original 2 gigahertz dual aggregated channel that has a bandwidth of about 20 megahertz. Now, an important aspect to mention here as well is that the PLL VCO is of such superior quality that it's also being used to clock the ADC. That's because the noise floor, as we are showing here, is 20 dB better than anything else available in the world today. That extra 20 dB worth of performance means that if you were to integrate the noise that's farther out, let's say out to a gigahertz offset past the carrier, that means that if you do a brick wall integration of what our noise contribution is that will be folded back into your sampled region of interest, the Hittite PLL wideband VCO fractional length synthesizer only contributes around 25 to 30 femtoseconds, whereas a competitor's device that's about 20 dB higher will contribute within this brick wall of phase noise integration out to a gigahertz. It'll fold noise back into your sampled region of interest of something like a magnitude of 400 to 500 femtoseconds, in comparison to our device, which is only about 25 to 30 femtoseconds in contribution. So quite a significant difference. And this shows with both using our synthesizers as an LO, or for clocking ADCs or clocking DACs, you'll achieve superior performance in a typical application like an LTE-A transceiver. Thank you very much for your time, and please visit hittite.com and check out these parts, and call us up, ask for a sample board, try them out. You'll really be amazed by the performance. Thank you very much.